Good morning, everybody. My name is Ferhan Mazher, and today is 25th of September 2020. And the subject today we are going to study is Physics 5054. And right now, I am with the 10 Cambridge class, and today's main target is to do MCQs on the topic of heat. And today we are going to work on, we will start the MCQs from the summer 2006 and we will continue them and we will see that how many questions we are able to do. So let's start, and the first paper from where we are going to do the MCQs. This is on your screen. I hope it's visible to you. The first okay, so this is summer 2006 paper, and we are going to attempt the MCQs which are on the topic of heat. So because we have completed the topic of heat, so we are now preparing it for exams and assessment. So today's target is to do the MCQs. And the summer series we are working on. So some of the question 15 is some of the more energetic molecules in a liquid leave the surface, leaving the rest of the liquid slightly cooler. What is the name given to this process? What do you think? What is the name given to this process?
Evaporation.
Evaporation. Yes, that's the answer. Evaporation. Evaporation. The more energetic molecules leave from the surface of the liquid, and the molecules which are left in the body of the liquid are less energetic. So the average kinetic energy of the molecules in the body of the liquid becomes less, so the temperature drops. So this is the cooling effect of the evaporation. So the C is the right choice. Question number 15, summer 2006 paper, question 15 on the topic of heat. C is the right choice. Do you understand?
Yes, sir.
Okay. So next question on your screen is, it says, so question 16 is on your screen. It says a substance consists of particles that are close together and moving past each other at random. The average speed of the particles is gradually increasing. So you see what best describes the substance. The particles are close together, like they are moving past each other. It's purely a liquid. The average speed of the particles is gradually increasing. When the average speed gradually increases, the kinetic energy of the particles increases. So the average kinetic energy of that liquid will also increase. Gradually, it will be increasing. So if the average kinetic energy of the particles of that liquid is gradually increasing, it means that the temperature of that liquid is gradually. What do you think? What's the best option?
B.
A liquid being heated. Yes, it's a liquid and its temperature is rising. It means you are heating. So B is the best option. Is this clear?
Yes, sir.
Yes, sir.
Okay, so on your screen we have question number 17. The paper we are attempting is summer 2006. Which thermometer is the best for measuring rapidly changing temperatures? Rapidly changing temperatures. Which thermometer is best for that purpose? A clinical thermometer? No. A liquid in glass thermometer? No. A thermocouple? Yes, that is the good thing about the thermocouple. It can change very rapid. It can measure very rapidly changing temperatures. A thermocouple is the answer. What do you say?
C.
C. Yes, C is the choice. Question number 17. C is the right choice, sir. Okay, we are moving to the next question. Question number 18 is on your screen. Some ice cubes are taken from a deep freeze and placed in a metal container. The container is heated at a constant rate and readings of the temperature and time are taken. The results are recorded on a graph. The temperature corresponds to which temperature corresponds to 0 degrees centigrade? Which temperature corresponds to 0 degrees centigrade? So what do you think? These are ice cubes.
C.
And their so
C. C.
C. C is the first time when the temperature graph becomes flat, which means that a state change is taking place because they were ice cube. They must be converting into liquid water. So the C, and this happens at 0 degrees centigrade. So C can be 0 degrees centigrade. So C is the best option. Do you understand?
Yes, sir.
Yes, sir.
Okay, so next question. Okay, this question is on the bimetallic strips. The diagram shows a bimetallic strip when it is at room temperature and after it has been cooled. The upper metal is brass and the lower metal is invert. So when you decreased that temperature, when you cooled it, it bended upward. When it bended upward, it means that the brass is contracting more and the invert is contracting less. That's why on cooling, it bended upward. Try to understand this concept. On normal temperature, the bimetallic strip was a straight horizontal strip. When you cooled it, when you dropped the temperature, when you decrease the temperature, the bimetallic strip bended upward. Why it bended upward? The reason can be because both the metals, they have contracted. You cooled it. So both of them contracted. But it bended upward, which means that the brass has contracted more and the invert has contracted less. That's the concept behind this. The change in shape occurs because the brass contracts more than invert. That's the right topic. Do you understand this concept?
Yes, sir.
This concept is not in the physics matter, but you might have done questions on this topic in your red spot. Have you done? Hello? Are you with me?
Yes, sir.
You have done. Okay. So you understand this one now.
Understood, sir.
Okay. Okay. So we are moving to the next question. Question number 20 from summer 2006 paper on your screen. Density changes are responsible for which method of thermal energy transfer? The difference of density causes the transfer of heat in convection. In convection only. So for question number 20, B will be the right choice. The transfer of heat takes place due to the difference of densities that happens in convection currents. So B is the right choice. Do you understand?
Yes, sir.
Yes, sir.
Yes, sir. Okay. So the next question, number 21, is on the topic of waves. So these are the questions on the topic of heat from the summer 2006 paper. We did question number 20, we did question number 19, 18, and 17, and 16, 15. Okay. So 15, 16, 17, 18, 19, and 20. These were the questions on the topic of heat from the summer 2006. Okay, let's move to the next paper. The next paper is from summer 2007. Summer 2007. So let me take out that question. Okay. So, summer 2007 paper. This is the MCQ paper. And we are working on the MCQs of the topic of heat. Question number 13 is on your screen. A liquid, let me precise, visible. Question number 13 is on your screen. A liquid is heated. Which statement is incorrect? Which statement is incorrect? The molecules expand. You see, the molecules do not expand when you heat them. The molecules do not expand. The molecules gain energy as when you heat, the molecules gain energy. The molecules move further apart. Yes, that's exactly what happens when you heat a liquid. The molecules move faster. The molecules move faster. A liquid is heated. The molecules expand, that's wrong. The molecules gain energy, yes. The molecules move further apart, that's true. The molecules move faster, that is also true when you heat a liquid. He was asking us to pick the one which is incorrect.
A, sir.
So who is incorrect? A is incorrect. The molecules never expand. The molecules never expand. So A is incorrect. So that is the right option. Question number 13, A is the right option. You understand, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so on your screen, we have next question. That is question number 14. Question 14 is showing on your screen. The paper is summer 2007. What describes the molecular structure of a liquid? What describes the molecular structure of a liquid? Distance between the molecules, they are close together. Yeah, in the liquid, they are close together. Motion of the molecules, they are moving randomly. In liquid, they move randomly. And strength of the forces between the molecules, they are fairly strong. So what's the option?
B.
B.
B is the right option. Somebody said C. B is the right option. Yeah, B is the right option. The distance between the molecules, they are close together. The motion of the molecules, they are moving randomly. And the strength of the forces between the molecules is fairly strong. The beauty of this MCQ is that if you can kind of remember these sentences, sometimes in theory paper, you will have to write these sentences. Okay? So don't take the MCQs in isolation. And there are the lines, the sentences, the language which think that can be used in the theory paper also. So for 14, the B is the right option. Let's move to the next question. On your screen, we have a question on, I think, Thermocouple. Yeah. On your screen, you can see question number 15. A thermocouple thermometer uses a voltmeter to measure the EMF generated between two junctions. The junctions are at temperature T1 and T2. To calibrate the thermometer, fixed points are needed. What are the values of T1 and T2 when the thermometer is calibrated at the steam point? You see, the hot junction should be at 100 degrees centigrade. And the cold junction should be at the 0 degrees centigrade when you calibrate your thermocouple. So T1 should be 0 degrees centigrade. And the T2 should be 100 degrees centigrade. Yes. So B is the right option. Question number 15. B is the right option. Everybody understands?
Ji, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So now we are moving to the next question. That is question number 16 on your screen. And this is summer 2007 paper. What is the definition of the heat capacity? It's not saying specific heat capacity. It's just saying heat capacity. Heat capacity is the amount of heat or quantity of heat required to raise the temperature of an object through 1 degree centigrade. The quantity of heat required to raise the temperature of an object through 1 degree centigrade. When I say heat capacity, I don't say 1 kg or 1 gram. Okay? So what's the best option?
A.
A.
A, A is the best option. So A is the choice. Question number 16, A is the option. You see, sometimes this statement can come in your theory paper also. They can ask you to write the definition of heat capacity. So the definition of the heat capacity is written here. The quantity of heat required to raise the temperature of an object through 1 degree centigrade. A is the option. Question number 17 from the summer 2007 paper is on your screen. The topic of heat, the MCQs related with the topic of heat we are attempting. Fillings in the teeth should be made from a material which expands more than the tooth when heated. If this happens, the filling will break or your teeth will also break. Expands by the same amount as tooth when heated. That's the right thing. Expands less than the tooth when heated, then the filling will be separated from your tooth. Does not expand when heated. That is wrong. We don't want anything which do not expand. So
So B is the
the
right answer.
material should, yes, it should expand as much as your tooth expands. Okay. So B is the best option. What you say? You got it?
Yes, sir.
Yes, sir. Yes, sir.
Okay. A double glazed window. A double glazed window has two sheets of glass separated by a layer of air. Thermal energy is conducted and convected through the layer of air. The amount of conduction and convection varies with the thickness of the layer of air as shown in the graph. So on this graph, on the y-axis, the thermal energy transfer is shown, and on the x-axis, the thickness of the layer of air is shown. So it has different effects on conduction and convection. Okay. Which thickness of air produces the smallest energy transfer and why? You see the combined effect on the transfer of heat is shown here by the dotted graph. The combined effect on the conduction and the convection is shown by the dotted graph. So where the transfer of heat is minimum, where the dotted graph has the lowest value on the y-axis. And what is the x value there? At that, and you can see this point, the x value here is 1 centimeter. So the layer of the glass should be 1 centimeter. Here, the transfer of heat by both the methods will be least. The total transfer of heat by both methods will be least. So 1 centimeter, because the total thermal energy transfer is least. B is the right answer. Which thickness of air produces the smallest energy transfer and why? 1 centimeter. From the graph, I am able to tell that at the thickness of 1 centimeter, the combined transfer of heat by both the method is least. So the thickness should be 1 centimeter. B choice. It's a little tricky question. Do you understand?
No.
Yes, sir.
You see, the transfer of heat by conduction and by convection through the air is shown here by the graph. But individual transfer is shown by the continuous line. Their combined transfer is shown by the dotted line. So his question is, where is the least transfer of heat? So I will check from the dotted graph, the graph which is by the dotted curve, because that is showing the total energy transfer. So where it is least, where it is, here is the, on the y-axis, the transfer of heat is shown. Where the value is least, here at this point, the value of the transfer of heat is least. So what is the thickness below this point? That is 1 centimeter. So B is the choice.
Okay, sir, समझ आ गई.
Okay, so you understand now. Okay. Question number 19 is on the topic of waves. Okay, so we have done question number 18, we have done 17, we have done 16, we have done 15, and we have done 14, and question number 13 from the summer 2007 paper. It is an MCQ paper. We are doing the MCQs on the topic of heat. Okay, now I am opening the summer 2008 paper, and we will go to question number 13, 14. From there, the MCQ start from the topic of the heat. So, okay. Okay. Question number 14 is on your screen. Okay, so this is summer 2008 paper. On your screen, question 14 is showing. In a vacuum flask, which methods of heat transfer are prevented by vacuum? You see, the vacuum, there are three methods of transfer of heat. One is called radiation. The vacuum cannot stop radiation. The other two methods are conduction and convection. Vacuum can stop conduction, and vacuum can also stop convection. So, which methods of heat transfer are prevented by the vacuum? Conduction and convection only. It cannot stop radiation. So, what's the choice?
C. C.
C.
So, C is the right. Question number 14. C is the right choice. Okay. On your screen, we have question number 15. And he says the diagram shows a liquid in glass thermometer at 0 degrees centigrade. The length of the liquid column is 2 centimeter. At 100 degrees centigrade, the length of the liquid column is 22 centimeter. What is the length of the liquid column at 40 degrees centigrade? Okay, so let me open the paint file so we can let me open it. So you remember the formula which you studied is L theta minus L naught divided by L100 . It's very difficult to write with the mouse. Unfortunately, I have mouse with the minus L naught equals to theta divided by 100. Can you do this? When the temperature is 40. Okay. So L theta is X. I don't know that. Minus. And L naught is 2 divided by, we did this question in the class also, in the face-to-face class. This is 22 minus 2 equals to 40 divided by 100. Can you get the value of X from here?
Yes, sir.
Get the value. It's very difficult to write with the mouse. It's easy. I have a calculator.
Sir, it's 10. Yes, sir, it's 10.
It's 10. Yes, the X value will be 10 centimeter. Do you understand?
Ji, sir.
Everybody?
Yes, sir.
So the answer is 10. So what's the option? What's the right option? D. D will be the right option. Question number 15, 2008 paper, summer 2008 paper. The right option is D. Okay, so question number 16 is on your screen. At regular intervals along a railway line, there is a gap between the rail sections. What is the reason for the gap between the rail sections? We always leave gaps between the rail sections. The reason is when it will be very hot, the rail sections, they are made of iron. So when it will be hot, that iron will expand. So we leave the space. So when they expand, they do not bend each other. So they have gap. So the expansion can take place. So H is to allow for expansion of the rail section during hot weather. That is the right answer. What do you think?
Sir, A.
A is the right option. Okay. Everybody understand this?
Yes, sir.
Okay.
Yes, sir.
Question number 17. Ice is taken from a freezer and left in a room. The ice melts and eventually the water reaches room temperature. Which energy transfer takes place? Energy transfer during melting. What will happen? The ice will be giving heat to the room or the room will be giving heat to the ice?
The room will be giving heat to the ice.
Yes, the heat always travels from the hot body to the cold body, from the region of higher temperature to the region of lower temperature. So during melting, the heat will be transferred from the room to the ice. And energy transfer after melting, even after melting, the water will be cooler than the room. So the heat will transfer from the room to the water. So what's the best choice?
C.
C.
C is the best choice. Yes, C is the best choice. Okay, so let's move to the next question. Question number 18 is right now showing on your screen. The paper is summer 2008. We are doing MCQs on the topic of heat. Some air is trapped inside a small balloon. The average kinetic energy of the air molecules in the balloon is increased. What remains the same?
B, sir. B, sir.
Yes, when you heat something, if mass do not change. Everybody understands?
Ji, sir.
Yes, sir.
So B is the right choice. Question 19 on your screen. A student is investigating the evaporation of water. The student can change the depth of the water, the surface area of the water, the temperature of the water. How many of these changes, if any, would alter the rate at which evaporation occurs? How many of these changes can change the rate of evaporation? Depth of the water has no effect on the rate of evaporation.
Sir, 2,
Surface
surface
area
area
of
of
the
water and
water.
temperature of water.
Yes, these are the two factors which affect the rate of evaporation. So he gave you three factors. How many of them can how many of them can alter the rate of evaporation? 2. The depth of the water do not affect the rate of evaporation. So 2. So what's the option?
C, sir.
C is the right option, ma'am. C is the right option. Question 20 is on the topic of waves. Okay, so that's it from the summer 2008 paper. Now we will move to the next paper, that is the summer 2000. Next paper is summer 2009. Okay, on your screen, we have summer 2009 paper. Let's go to question number 13, 14. From there, the topic of heat starts. Okay. Here we go. From question number 14 in the summer 2009 paper, the MCQs are on the topic of heat. It says the diagram shows that. Okay. The diagram shows 4 identical cans with their outside surfaces painted either dull black or polished silver. Each can contains the same volume of water initially at 80 degrees centigrade. After 5 minutes in a cool room, which can contains the coolest water? So it's the heat is being given out. Okay. Oh, all the 4 cans, the temperature of the water in them is 80 degrees centigrade. So we put them in the same room. So which will be more cooler?
C, maybe.
C has a lid on it. So the thing which has lid will have less transfer of heat as compared to the ones which do not have a lid on them. The
B.
ones which have the lid on them, they will lose heat faster.
Okay, it's not cool. A.
So,
A. Sorry, मैंने पढ़ा ही नहीं आपको.
okay, so A can be the answer because its outside is painted dull black. And you know, dull black, when the body is hot and the color is dull black, it's a very good emitter of infrared radiation. So the dull black will lose heat very fastly. Plus, there is no lid on it. When there is no lid on it, the evaporation can take place very fastly. When the evaporation will happen, the heat loss will happen. So in the A, the liquid will be the coolest after some time. You understand?
Yes, sir.
Sir.
Everybody understands? On your screen, paper, summer 2009, question number 15. What makes a liquid in glass thermometer sensitive to a small change of temperature?
D.
A bulb with a thin glass wall? No. A shiny liquid in its pore? No. A stem with a thick glass wall? No. A very narrow board? Yes, that is the thing which affects the sensitivity. A
D, sir.
very narrow board. D is the right choice. What do you say? You understand, everybody?
Yes,
G,
sir.
sir.
Okay, so next question is on your screen, summer 2009 paper. The question is 16, question number 16. A substance that is originally a solid is heated strongly for some time. At one stage, the energy given to the substance is used as latent heat of vaporization. Latent heat of vaporization. At this stage, what change does the energy cause? At the latent heat of vaporization, the liquid is converted into gas. Latent heat of vaporization means that the liquid is converted into gas. It breaks the bond holding the molecules together. Molecules escape from the liquid. That can be the answer. It breaks the bond holding the molecules together. The solid becomes liquid. That's wrong. That's wrong. Latent heat of vaporization is liquid converting into gas. See, it makes the molecules move faster, but there is still a strong attraction between them. That's wrong. It makes the molecules move faster and so the temperature rises. That is also wrong. During the state change, the temperature do not change. They do not move faster. Means their speed do not further increase. So what can be the best option? A is the best
A.
option. Understand? Everybody understand?
Yes, sir.
Fatima Zia is everybody. There are 12, I mean, at least there are 9 girls in this session. Okay, so question number 17. What happens when a metal bar is heated? What happens when a metal bar is heated? You see, the metal will expand. When the metal expands, its molecules move a little away from each other. Okay? When the solid will expand, its molecules will move away from each other. Plus, they will start vibrating more quickly. The distance between the molecules increases, making the bar longer. That can be the answer. The molecules get larger, making the bar longer. Molecules never become larger. The molecules never expand. The C option is the molecules vibrate more quickly, making the bar denser. If they start vibrating more quickly, the bar will not become more denser, it will become less dense because the volume will increase, the mass will be the same. The speed of the molecule increases, making the bar thinner. That's wrong. It will not become thinner. So what's the best option? A. The distance between the molecule increases, making the bar longer. That is the right option. A is the right choice. Okay. Question number 18, summer 2009 paper is on your screen. A fixed mass of gas at constant temperature is compressed to reduce its volume. How do the molecules of gas now strike the wall of the container? A fixed mass of gas at constant temperature. The temperature is not changing. So P1 V1 equals to P2 V2. Famous equation, Boyle's law, is compressed to reduce its volume. How do the molecules of gas now strike the wall of the container? Because you have decreased the volume of the gas and you have kept the temperature constant, the volume has been decreased. So now there will be, remember this sentence which I say, now there will be more number of molecules per unit volume. So the collision, the number of collisions with the walls of the container will increase.
सर डी होगा या सी होगा?
With a higher, so see in C, he says more often than before with a higher velocity. But we are saying that temperature has not changed. When the temperature has not changed, their kinetic energy has not changed. If the kinetic energy has not changed, it means their speed has not changed. So you cannot say with a higher velocity. So
So
D,
it's D.
more often than before with the same velocity. So D can be the answer. What do you think?
I think D is the answer.
C.
D is, D is the right answer. So it's little tricky. This question is little. You understand?
Yes,
Yes,
sir.
sir.
So that was question 18 from summer 2009 paper. Question number 19 of this paper is on the topic of waves, which we had to study. So that was the summer 2009 paper. We have done question number 18, question number 17, question number 16, question number 15, question number 14. Yeah. So from 14 we start. These were the MCQs on the topic of heat. Okay, on the whole topic. So that was the summer 2009 paper. Now let me take out the summer 2010 paper. In the summer 2010 paper, there are two papers basically. One is paper 1-1 and another paper is paper 1-2. It's showing picture. Paper is not showing that paper again. Okay. So I have just opened this summer 2010 1-2 paper. From 2010, we have two variants, 1-1 and 1-2. Okay. So let's do this paper. It's MCQs. The MCQs in a yearly paper, MCQ paper starts on the topic of heat, start from almost from question number 14 or 13. Okay. So on your screen. So everybody, this is summer 2010 1-2 paper and we are doing the MCQs on the topic of heat and this is question number 14 is on your screen. An ice cube has a mass of 7.50 grams. The ice cube is at 0 degrees centigrade. Heat from the surrounding reaches the ice cube at an average rate of 1.25 joules per second. How long does it take for all the ice to melt? Specific latent heat of fusion of ice is 333 joules per gram. So how much time this ice will take to melt? So let me take out the paint and let's start. When something melts, the heat is equal to how much? The Q heat, heat equals to, you remember, ml. Remember this formula? M
Sir. M into L.
multiply M is very difficult with the mouse. M into L. Okay. So how much is the mass of the ice? How much is the mass of the ice? It's 7.5 grams. Okay. And what is the latent heat of fusion? That
33.
is 7.5 grams. And you have that calculator thing? 330 joules per
Sir,
gram.
2497.5.
So the answer is
2
2000
4 2497
4 9 7
7.5. 5.
5 joules. Okay. So this much heat is required. And the power, you remember power is equals to, power is equals to heat divided by time. So if you want to find out the time, so it will be, the time will be heat
Divided by power.
divided by power. So you have the calculator. So
Yes.
just do this calculation. 2497.5 divided by the power. The power was how much? The power was 1.25 joules per second. Can you get the answer?
1998.
1998, approximately 2000.
So the answer will
Approximately,
be 3.
it will be approximately 2000 seconds. Everybody
Yes.
understand this numerical?
सर पावर
Yes.
में हम 1.25 joules per second को क्यों कंसिडर कर रहे हैं?
Because that is the power given in the statement. The rate of transfer of heat means power. We say power or we say rate of transfer of heat. That means power. It is given in the question. If you look at the statement of the question, it is given in the question that the rate of transfer of heat is 1.25 joules per second. That is power. Okay.
Yes, sir.
Do you understand? Everybody understands?
Ji, sir.
Yes, sir.
Okay. 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 Here we go. Question number 15 is on your screen. The liquid in a puddle evaporates. Puddle. You know, we have done this. And
Yes,
this
sir.
causes its temperature to change. And this causes its temperature to change. How does the temperature of the liquid change and why? Because the evaporation will be happening, the water in the puddle, and it's evaporating. So the temperature will change. Because the evaporation is happening, evaporation always have cooling effect. So
It will
the
decrease.
temperature will change, it should decrease. And the reason is because more energetic molecules leave the liquid and less energetic molecules are left in the liquid. So what do you think? What is the best option?
B.
B, baby.
B.
B is the right option. B for baby. B is the right option. Question number 15, summer 2010, 1-2 paper. Understand everybody?
Ji, sir.
Okay, good. Okay. Question number 16. A bimetallic strip made from brass and iron is used as a thermostat. So brass and iron. Brass is on the upper side and the iron is on the lower side. When the strip is heated, the brass expands more than the iron. The brass expands more than the iron. Which shape the strip becomes? Straight. The brass is on the upper strip. The iron is lower strip. The brass expands more. Iron expands less. Because the brass is on the upper side and it expands more. Iron is on the lower side and it expands less. So what will happen is this bimetallic strip will bend downward. Because the one which is on the upper side, it expanded more. So its length will be more. Okay? After expansion. So it should bend downward. B choice. Do you understand?
Ji, sir.
Yes,
sir.
sir.
Okay, good. So here we go. Question number 17. Paper summer 2010 1-2. Question 17 on the topic of heat. When a refrigerator is switched on for the first time, the air surrounding the ice box is cooled. What happens to the density of this air and to its position inside the refrigerator? So here is the ice box. Here is the ice box on your screen. You can see So the air here, when it becomes cool, it becomes dense. It becomes dense. And when it becomes dense, it sinks to the bottom. So the density will increase. The density will increase
See?
and it will sink to the bottom. You understand?
Ji, sir.
Yes, sir.
That was question number
Yes,
17.
sir.
Okay, the next question is from the topic of light. So that's it. So today with this class, we have done summer 2006, summer 2007, summer 2008, summer 2009, summer 2010, 2-1 paper. We have done MCQs on the topic of heat because in our class we have completed the topic of heat, all the chapters which were related with the heat, we have completed them. In the next we are going to start the topic of light. So
Okay,
that's
sir.
it. So I will switch off the recording, but before you leave this class, kindly tell me your name. I will mark your attendance, but after I stop recording. So thank you very much, everybody. All the people who are watching me online. So thank you very much, everyone. My name is Ferhan Mazher. Today is 25th of September 2020. Right now, I was with my 10 Cambridge class, and we were working on the MCQs on the topic of heat. We have done from 2006 summer paper till 2010 summer paper 2-1. Summer paper 2010 1-1 we have not attempted in this session because our class time has over. So thank you very much, everybody. Have a good day. God bless you all. Lot of blessings. Thank you.